Hello, everyone, and welcome. My name is Sierra King, and I am the Director of Admissions and Program Services at the Data Incubator, and we are a fellowship, scholarship, and placement company. We've promised you an excellent info session today that will be led by one of our instructors, Richard Ott, and we will be sharing tips and tricks for those looking to launch their data science career. To start things off, I would like to give you a quick overview of our programs and everything that we offer. Then I will hand off to Rich, who will lead us through our discussion, and we will leave some time for questions at the end. Speaking of questions, if you could please place all of your questions in the Q&A section, and we will answer them at the end of the presentation. As a reminder, our session is an hour long, so if we don't get to all of your questions today, please email us at admissions@thedataincubator.com, and we'll be happy to help you. We'll also post a link to our email address in the chat at some point in this presentation as well. So to start us off, the Data Incubator focuses on training people to become data scientists and data engineers. And we get the question a lot is, why is that important? Well, it's really because data professionals have the ability to work with the latest tools on unstructured and structured data to drive business value. This is a big need in the world right now. We work with companies in a variety of industries ranging from tech to finance, healthcare, biotech, many more. Every company has data and wants to use this data to drive value for them. And we know there are a lot of data-focused programs out there, so I'm sure you're wondering what we do at the Data Incubator that's just a bit different. Well, what we found is when you look at training, there are really two different types, one being fast-paced and efficient, and two, slower and focusing on understanding and completion rates. University is one example where you'll receive a more detailed understanding, but with a lot more time invested. And then on-the-job training is usually very quick and efficient, but maybe you're not fully understanding what it is you're doing. Well, at the Data Incubator, we've taken all of these aspects and combined them together to find a great middle ground for our training. Our program is fast-paced. You walk out of the program knowing a lot about data science and data engineering, but most importantly, the real-world business applications, and with a deeper understanding as you get from university. All of our instructors are PhD or master holders, and many of them have completed this program themselves, so they know how to provide that in-depth training that you are looking for. And for our summer 2022 cohort, we'll be offering 3 data-focused programs. We'll be offering our successful full-time data science fellowship program, and a more flexible version of that, our part-time data science fellowship program. And we are also offering our data engineering program as well. I do want to take some time to review the similarities and offerings for all 3 of our programs. All of our programs are intense. They are built around hands-on data-focused curriculums. We offer both full-time and part-time programs for our data science program, and both are packed with a lot of information and tools. They're thorough. Each week focuses on a different data tool or approach. And in addition to our lectures, we have our students participate in hands-on practice. We really believe in fostering an interactive learning environment, and so in each program, students will work on mini projects that focus on the data tools you're studying. Additionally, our programs are very collaborative. We want our students not only to work with their colleagues and instructors, but have the opportunity to network and connect with our hiring partners as well. And our programs are all career focused. We have career coaches that help you succeed in your data-focused careers. You'll learn not only how to present your best self by attending our career search lectures, but you'll also have the opportunity to work with a #1 resume writing company to get you a polished resume and cover letter. And lastly, all of our programs are interactive. Every student in our programs are provided a Jupyter server for the duration of the course, so students can follow along in lecture and see and edit raw code that's being run. And students will also receive immediate feedback via our interactive grader. So for our full-time program, the full-time data science program lasts for 8 weeks with classes held daily, and you can expect to spend about 40 hours per week in class or outside of class working on your assignments. Here's a quick overview of our curriculum broken down week by week. If you'd like to see a more detailed overview of our curriculum, again, please email us admissions@thedataincubator.com. We'd be more than happy to share that with you. For our part-time program, that program lasts for 20 weeks with classes held on Tuesdays and Thursdays from 7 to 9:30 Eastern. And you can expect to spend about 10 hours per week outside of class working on your assignments. Office hours are also available each week in our part-time program. You'll receive the same excellent curriculum and training as our full-time program, but at a much slower pace. And these sessions are live and instructor-led, so you're still able to interact with your instructors and your peers and ask questions as well as network. And for our full-time data engineering program, that also lasts for 8 weeks with classes held daily. Again, you can expect to spend about 40 hours per week outside of class working on your assignments. And then here is an overview of each of the modules in our program broken down week by week. And again, if you'd like to see a more detailed overview of our data engineering program, we are more than happy to share that with you if you send us an email to our admissions inbox as well. So that is just a little bit about our programs. I will now pass off to Rich to lead us through our discussion today, and then I will come back to help answer any questions at the end.
All right, thank you. Sarah, can you unshare your screen? Yeah, thank you. All right, so hello everyone, my name's Rich. I am a data scientist in residence at the Data Incubator. I'm one of our instructors. I'm based out of the San Francisco area, so if you do join the program and you work with the West Coast group, I will most likely be seeing a lot of you. Today's topic is getting started in data science. That's why you're here, I presume. So I want to talk a little bit about what is data science, what data scientists do, what skills you're going to need, how do you get those skills, what companies are looking for. In particular, I'm just going to walk through basically that in order. What's data science and data scientists? What kind of skills you're going to need? And I'm going to talk both about starting skills and a little bit more advanced skills. How do I get into the field? And what is TDI bringing to the table? So start with, what is data science? Well, data science really lives at the intersection of a bunch of fields. And it's a fairly modern thing. It's really only been around for maybe 15 years. It is very much a process for using data to solve practical problems. It is very problem-focused, very goal-oriented, trying to solve problems. It is combining, as I said, several fields. And so I've got here a little diagram. You're combining programming, mathematics and statistics, domain knowledge, so understanding what the context is for data you're analyzing, and an experimental viewpoint. There is a lot of trial and error in this process. There's a lot of trying different things out and seeing what works, testing things. It is an experimental science, and so there's a little bit of art to it. And the idea here is, as Sierra said, that there is more and more and more data available every day. And everything's being monitored now. There's tons of data available around the world. Companies and other organizations really are trying to take advantage of it. And they need people who know how to take this data, extract useful insights from it, analyze it to get whatever is buried in there that they can use, and apply that and communicate it to others. And really, this is the data scientist's role. And so I will be focusing on data science as opposed to data engineering, which is a related thing with a lot of overlap, but has a slightly different emphasis. And we can maybe talk about data engineering a little bit in the Q&A session. Another common definition you hear for data science is it's a method for handling this ever-increasing volume of data and the more complex data we get every day. This data that's coming in as pictures and data that's coming in as text. And that is a part of it as well, but the core of it is using data analysis techniques to solve practical problems. So that said, what does a data scientist do? Well, data scientist actually winds up wearing lots of hats and doing lots of different things. But the core of what a data scientist does, unsurprisingly, is work with data. Data from the real world is messy. It contains inconsistencies. It comes in lots of weird file formats, and it's a jumble. And a big part of what a data scientist does is takes this data, cleans it up, organizes it, processes it, and gets it ready for analysis. Just figuring out how to fix all the problems that exist, how to make it consistent. This also often involves taking data from multiple different sources and combining it. So I may have data over here about my customers and data over here about something else that's going on in my organization, and realize that if I put them together, I can get more insight as to what's going on. Often this involves taking multiple threads of data from within my organization, but sometimes I augment this data with external information, information I get from the census, information I get by scraping the web somehow. This is all part of what a data scientist does, looking for how I can take the data that I've cleaned up and make it better and more useful. Once it is amenable to being worked with, it's time to explore this data, figure out what's going on in it, start to look for some patterns, and visualize the data. This is really important. People are really bad at looking at raw data, including data scientists. So this process of visualizing the data as I go, making good graphs that show me what's going on is really important. We also, of course, analyze this data, extracting the wheat from the chaff. There is a lot of noise in data, and there are often very, very subtle patterns that we're actually looking for in data that are masked by everything else going on. And this is where a data scientist really shines, is they're very good at polishing the data down to make it something useful. And the analysis really ranges quite the gamut from basic statistics, just looking at means over time or something, to more complex models, up to using powerful machine learners. And these machine learners are able to find very subtle connections and patterns within our data, find relationships for things that are not obvious. And so this is often a focus of data science education, including TDI, but it is really important to also make sure you're using the right tool for the job. Sometimes you don't need that power. And that's knowing when to do that, also part of what a data scientist does. And the big thing that really sets a data scientist apart from just someone who's a technical person that's good at analyzing data is the communication aspect. And that really just is something that companies are very hard pressed to find, is people who are good at both the analysis and communicating that analysis. And here communication can be presenting and giving a report, writing a document, things like that, communicating the results of your analysis, communicating what you found to someone in the business who makes a decision, or it can be building some sort of tool. Maybe I built a machine learner that predicts something about customer behavior, and I want to set that up so other people can use it. Those both fall in this communication camp. Also, data scientists often wind up automating things. I said they wear a lot of hats, right? So that can be taking your analysis that you've done and setting it up so that next time data comes in, it just gets processed, or you can just process it with the touch of a button. Or it can be taking some sort of common business task that people are doing in spreadsheets or something and turning it into something that is repeated with just, again, the hit of a button or a small, simple task, simple command line. You will hear about data analysts, data scientists, and data engineers, and they are in some sense distinct, but the boundary between them is extremely fuzzy. And so data scientists often wind up doing a bit of the analyst role and a bit of the engineer role just as part of their job. The engineers and analysts are a little more specialized in various ways, and data scientists a little bit of in the middle. As such, again, since this is at the intersection of so many fields, there's a huge variety of skills that data scientists bring to the table. They are a bit of a jack of all trades. They need to have the ability to do lots of different things, and again, because they wear so many hats. I'm going to talk through the next several slides, the kind of skills you're going to need. Mostly I'm outlining the basic skills, the ones you're going to need to really get started, but I'll have some more advanced things in there that things you would pick up over time. And one thing I'm going to emphasize over and over is that you really need to learn by doing. You really need to learn this stuff in a hands-on manner. If you just read about it and you have a theoretical knowledge, that is nice, but it's not useful. This is a practical field. We are doing stuff. You really need to practice, practice, practice. And the hands-on is so important. There's also domain knowledge that you can bring in. This is knowing about the business, the field that the business is in, or the organization you're with is in, and it gives you context. This is where your stuff you've been learning before you started becoming a data scientist really helps. If you have a background in biomedical stuff, or medicine or biology, then that's something you can bring in, that domain knowledge you can bring into a biomedical company, and you can put things in the appropriate context. I'm also going to note on each slide ways you can help yourself stand out, things you can learn that put you sort of one step above the crowd. So to start with, of course, lots of math, lots and lots of math. Data science is a technical field, it's a statistical field, lots of math. You'll really want to have a handle on the basics here, how to deal with common situations, how do I apply these things. As you gain experience over time, you'll learn how to put these into more complicated situations. And so here, of course, I put calculus because everyone needs to know calculus. The fundamentals involve more advanced mathematics. And statistics is a huge thing in data science, again, statistical field. You want your basics, your mean, median, mode, how do I deal with histograms, that sort of thing. You'll need to know about at least some basic regression, linear and multilinear, and if you can, nonlinear regression. Working with conditional probabilities shows up a lot. Hypothesis testing is really very important. And this is again where you can get this basic versus advanced split. Hypothesis testing, you can work with simple hypotheses, or you can work with very complex ones with lots of moving parts and lots of different data sets and testing several things at a time. And that's sort of something you would pick up over time, but have the basics under control, things you'd learn in the first couple semesters of statistics course. Data scientists also work a lot with linear algebra. Now, you don't have to completely master the field, obviously, but understanding the basics, because machine learners underneath are basically all linear algebra. And you will have to deal with that and have to work with that. So understanding your matrices and how to multiply them, and maybe how to do a little bit of eigenvalues and that sort of thing, really something you need to get started. To make yourself stand out, obviously you can learn any of these topics in more depth, or you can start learning more advanced topics like Bayesian methods. This is a different way of thinking about statistics than is traditionally taught in statistics courses. It's a different emphasis on how the pieces work together, and leads to some quite advanced techniques that can be used in a lot of situations to do quite a lot of very complicated analysis. If you're not familiar with Bayesian techniques, I recommend at least looking at the term. Again, this is something you can learn to make yourself stand out. It's more advanced. How do I handle data sets of various sizes? If I have a very small data set and a very large data set, I'm going to need very different techniques. For the very small data set, I might need to do something like bootstrapping to take advantage of modern computing power to extract what I want to learn. If I have a really big data set, well, I might need to do some subsampling or resampling to get it down to something that's more manageable. How do I do that correctly? Also, sampling techniques in general are a topic that shows up from time to time, and sometimes we see companies looking for people who are good at this. How do I design an experiment? How do I go about testing whether something's working or not? How do I collect this data? How do I make a good sample? How do I do A/B testing? Once you've got the math under control, or at the same time, we're going to be doing a lot of programming. Data scientists it's a computer-driven field. You're going to be automating things. You're going to be doing a lot of programming. You're working with data that's huge, so you can't just do it in Excel. And sort of one of the places to start is picking a language. The most common in data science are Python and R. Python is more common in industry. R is more common in academia, but there are a lot of companies that use R. I say pick one, go for it. I'm going to talk about Python here, both because that's the one I'm most familiar with and because that is the one that's most common in industry. You don't need to be a software engineer. That's not the goal here. You don't need a CS degree. You need enough programming knowledge to get by. Can I build a program that will analyze data? Can I build something that will accomplish the task I'm trying to accomplish? I don't need to have all the fancy business around it about hardening it and security and all of that. That generally isn't a data scientist's purview. That's pushing more into software engineering. Data engineers do worry about that some, but that really is pushing well into software engineering. But you need enough, again, just to be able to accomplish your tasks. I have some key ideas in Python here that you need to have a mastery of. These actually apply to pretty much any programming language. R might be an exception, and that is knowing the common data structures. In Python, the common ones are list, dictionary, and set. There are some more advanced things you should probably learn a little bit about, which are heaps, graphs, queues, linked lists, those sorts of things. But again, that's a slightly more advanced technique, worth looking up though. Working with loops, making functions, how do I break my code into functions to make it more modular? Classes, how do I work with classes? How do I make my own classes? How do I use those to solve problems? I've listed out here code design and modular programming. These are really more advanced topics you pick up over time, but if you can get a head start on those, that's great. Designing a program, how do I put together the pieces? How do I break it apart so that it's easy to maintain? How do I make sure that each piece of my program is doing a small task that I can build into a larger task? That sort of thing is a really good thing to at least start thinking about, and it's something, again, you pick up with experience. If you want to stand out, again, besides mastering the topics, you can learn other languages. C++ and Java are probably the two most common. Having both Python and R is good as well. There are other languages that are showing up a lot. Rust is becoming more common, Go is becoming more common. But C++, Java, and Python are probably the most common languages you're going to run into. Pick up another language if you don't already know it. That's a great way to stand out. Learning about command line tools, working in Bash, working with Git. Bash is, well, it's a command line tool in Linux. It's how you work with a Linux system, or at least it's one way you work with a Linux system. It's a set of common interfaces to give the operating system commands. There are a lot of command line tools that go with this. They let you do all sorts of fancy things very quickly. Having some control over that is really helpful. Git is a code versioning system. There's several others, but Git's the most common. It is tracking code over time, so you can keep track of how things have changed, what you've done, what has happened since the last version of this code. We hear this a lot from companies that they wish their new hires knew more about Git, often about command line tools as well, but particularly with code versioning in Git. This is something that we hear a lot. And it's something, again, you have to practice. So if you're going to do a project, I recommend trying Git, testing it out. Another thing that's useful and a little bit more advanced to help yourself stand out is learning about testing, automating tests, building code that's easy to test and can be tested, and learning these continuous integration tools. This is a system whereby every time the code is changed, the system automatically runs some tests and makes sure it works. So the most common one is Jenkins, but there are several others. There's actually many. I think there's probably at least a dozen of them. So learn a bit about how they work. These are things you can do a little more advanced to help yourself stand out. Of course, we learned all of this to do data manipulation, to learn about data. As I said before, this is where you spend most of your time. The numbers I often hear bandied about, and I think this is accurate, is you spend 80 to 90% of your time managing data, cleaning it up, preparing it, getting it ready to work with, fixing problems with it, and 10 to 20% of your time doing the fun stuff like machine learning, just the nature of the beast. So you'll need to be able to do a lot here. You need to be able to read and write from various formats, things like CSV, JSON, XML, Excel, various binary formats. If you can handle those 4 basic ones, you're in fairly good shape. A lot of the binary formats just have specialized tools, but knowing roughly how to work with those, how to read documentation for a new format or a new tool, working with databases, learning SQL. SQL is a necessary thing. Everyone has to learn SQL. It's just a fact of nature. SQL is ubiquitous. It is the interface for working with a database, and you will be working with databases a lot as a data scientist, either reading your data from a database, writing your data to a database, or both, most likely. So you'll take your data, you'll clean it up, you'll push it to some database, and then when you're doing analysis later, you'll read from that database and join it with other databases. That's, again, just how this works. As I said with this, you'll be spending a lot of your time cleaning your data. Again, it's most of your time, and that's things like fixing different formats. If you have data from different sources, how do I get them to line up? If I have data from different time periods, how do I get them line up? Did things change over time? Do I have gaps? Do I have errors? How do I fill them in? How do I fix them? How do I make my data nice and uniform so that I can write it to that database or work with it later? How do I combine multiple files? Often data comes in not as one jumbo CSV that I can read, but maybe 1,000 little CSVs or 150 JSONs, and I have to figure out how to mush them together. How do I handle semi-structured data? And that is your JSONs and your XMLs and your YAMLs. And that's things where it's not a nice table, so you can't just load it into Excel or Pandas. You've got to do some work to get there. How do I work with that? How do I take a JSON, take it apart, and turn it into something I can load into Excel or Pandas? How do I get it ready? It's called semi-structured because there is a structure there. JSON and YAML are very well structured, but that structure is not a simple table. It's more complex. It can be nested in something complicated. In Python, a lot of this work will be done in Pandas. least the more refined work will be done in pandas. This is a tool that basically works with tabular data tables, and you can do filtering and aggregation and all sorts of transformations and cleaning. You do often have to do some work to get it there. So again, if it's JSON, you have to clean it up first, but it's a very useful tool. You really should know pandas if you're going to be working in Python and have a good handle on that. You'll make yourself stand out, besides, again, mastering all of these. You can look into learning about NoSQL. NoSQL is a competitor to SQL, as you might guess from the name. Also might guess from the name, SQL is so common that the competitor called itself NoSQL to point out that it's not SQL. This is another way of storing databases, and this stores databases actually as semi-structured data. So this is becoming more common, and if you know about these, it really helps you stand out. As do learning about ETL pipelines. ETL stands for extract, transform, load. It's the process of taking data, cleaning it up, and preparing it to be put in a database and actually putting it in a database or something similar. And the pipeline aspect is building an automated system that does that for you. As data comes in, the system picks it up, cleans it up, and puts it where it needs to go. And so if you can learn a bit about how those work, how that automation process works, that will give you a big leg up as well. There are many tools for this, many tools for this, and it's a little bit context specific. So if you're working in Amazon Web Services Cloud, there's a pipelining tool. If you're working in Python, there's probably 24 of them. So you have to look at what the context of what you're working with is. You'll be doing a lot of machine learning as a data scientist. I hope that's not a surprise to anyone. You'll need to know a bit about machine learning theory and how to implement it. I don't mean how to write the code yourself. That's not the goal here. What I mean is, how do I take the tools that exist, like scikit-learn in Python, and use them to actually build one of these things? So if I wanted to, I would want you to know about, let me start that over. I would recommend that you know sort of the basic concepts here about supervised and unsupervised learning, regression versus classification, how they differ, how you do one versus the other, how you prepare data for these. Dimensionality reduction and clustering are the two most common unsupervised learning tasks. I would recommend knowing those two if you're going to know two unsupervised learning tasks, but there are many others you can learn about as well. How do I deal with this problem of overfitting, which is something that shows up in supervised learning, and tuning hyperparameters. So hyperparameters are things you can use to adjust the model, use to adjust your machine learner's behavior. How do I work with those? What are, for a few common models that I'll be using, what are the hyperparameters? How do they work? How do I adjust them? What are good ranges of values to try? And do this for a few models. Pick a few common models that you want to work with, maybe decision trees, random forest, linear regression, one or two others, and really understand how they work. Don't try to master all the models. That's impossible. There's literally hundreds of them. And this applies to my next statement as well. This is a bit more advanced, but if you can learn the details of how a few models work, that's going to really help. You don't need to be able to implement the training process for a decision tree yourself, but just have an idea of how it works. And how do I put these models, how these models work inside, what's going on under the hood. Just for a few common ones, again, this is slightly more advanced to help yourself stand out a little bit, but for this hyperparameter tuning, that is something you really do need to know for a few common models. How do I get data ready for machine learning? How do I clean it up? How do I do some basic feature engineering? Feature engineering here is taking my information that I have and transforming it so that the model will be able to work with it better. The simple stuff that you need to know going in is, how do I deal with data that's not just numbers? Well, you might need to do one-hot encoding if it's categorical. You might need to do some other kind of transformation. What kind of transformations do I need to do to make my model happier? Things like scaling the data so that it's all sort of 0 to 1 kind of data. Adjusting the data to be more what your model's looking for. So your model's linear. How do I adjust my data to make it look a little more linear to make the model happier? Simple combinations of features, taking a couple of features, mixing them together to produce cross features. That's the basic stuff. The more advanced stuff you would pick up over time or learn if you're ambitious would be, what do I do if the columns are correlated? How do I decorrelate them? Do I need to? How do I inject human knowledge into this system? So if I have latitude and longitude, is that useful? Is it not? Do I need to transform it into something like distances from specific places? What kind of transformations would be appropriate for that? If I'm working in a specific domain, which presumably you are, what kind of things are specific to this domain? So if I'm working with stocks, the average volatility over time is something that shows up, and that's pretty stock specific. It doesn't show up in a lot of other places. So those sorts of transformations I would consider more advanced. As I said, scikit-learn is the tool in Python that most people wind up using. That's the most common by far. It's a very good tool for building models and training them. It's great for that. It's not so great for production. It's not something you would necessarily expose to the internet, but again, that's where your software engineers would pick this up. It also is lovely because it has fantastic documentation. And that really helps here because it helps you not only learn about it, but learn about other stuff too. If you want to stand out, learn about natural language processing, working with human text. Learn about working with time series. This is extremely common in our slightly more advanced topic. Learn about neural networks. In neural networks there's a lot of different packages. The most common are PyTorch and TensorFlow. PyTorch really is used more in academia, and TensorFlow is used more in business. But again, companies use both, so it depends on the company. Another huge thing is communication. Being able to present your ideas clearly and appropriate to your audience. What's the right level of technical depth? Am I presenting to business folk, in which case I want to really scale back the technical depth and just keep the important points about how it works and the results? Am I talking to other data scientists where I probably want to show a little bit more about what's going on under the hood? How long is my talk? If it's 5 minutes, I'm pretty restricted on how much depth I can go into. If it's 25 or 30 minutes, maybe I can go a little more depth. What is appropriate to my audience in terms of what they want to know, what is relevant to what they need, what they're doing. Really a practical communication style, getting to the point, problem focused. We set out to do this, here's what happened, here's how we did it. This is in contrast to an academic style, which often meanders and has a long wind up in a half an hour intro and is trying to show off a little bit. That's no good, that's not what you want. You also want to be able to make good visualizations, easy to understand, and get your point across. Again, this is this to the point practical thing. Communicating what you want your audience to know. Learning a little bit about visualization theory can help here. In Python, the tools that are most common are matplotlib and seaborn for making static graphs. So just standard graphs. Altair, Bokeh, Plotly, and several others are used for making interactive graphs. I'm sure you've interacted with these on the web where you click on them and they change. You can make those. I would recommend learning at least a little bit how to do that as a start, and even for the basics. Don't choose Altair, Bokeh, and Plotly. Pick one of them to learn. Once you have one under control, you're in good shape. Again, your company may choose a different one, but once you know one, learning the others isn't so bad. I also have these dashboarding tools, Power BI, Tableau, and then usually companies have their own internal dashboard. Data scientists often wind up making dashboards, but usually not in Power BI and Tableau unless the company is really bought into that. I know some companies we work with are really big users of one or the other. Tableau has a nice free thing called Tableau Public you can practice with. And one really important thing here is that you need to actually do this. You need to make presentations, you need to make graphs, you need to show them to other people, you need to practice this to make sure it's working. It's very, very difficult to make one and decide yourself if it's working. So you need to show it to others, you need to practice. Again, that's an ongoing theme, but you do need to do this. How do you make your stuff stand out? Well, the biggest thing we get from companies all the time is we need people who can take these technical things and talk to non-technical people about them, particularly our business people. This is just enormous, and it's something we get all the time. It really is what makes a data scientist stand out. Taking this, communicating non-technical people, putting it in the context of the business and how it's addressing the business needs. You'll hear a lot about big data. I would say all of this stuff I'm about to talk about is above and beyond the call of duty. It is things to make yourself stand out. And that's working with large data sets, where large here is too big to fit in memory, and working with what's called unstructured data, things like image files, sound files, human text, things that aren't numbers or JSONs that you can turn into numbers, things that are much messier. This involves a lot of work, obviously. One big aspect of this is often distributed computing, using multiple computers on a single task. And there are many different tools for this. I've listed the 3 most common ones: Spark, Dask, and Hadoop. There are many, many others as well. Basically anything in the Apache project. We teach Spark when we do this. And so this is, again, a technique for having all these computers work together. It handles the communication between computers for you, so you don't have to worry about that. So these frameworks are really lovely, because if you have worked with MPI, the old way of doing it, you'd really appreciate the new way of doing it. Another thing that winds up here a lot, and this maybe sometimes shows up anyway, is cloud computing. This is computers you can rent. So I can just go and say, hey, give me 10 computers, and press a button to get 10 computers. These are often used to handle these larger data sets, because you can just rent computers on demand. There are several of these. The 3 biggest are Amazon Web Services, Google Cloud, and Microsoft Azure. Amazon Web Services has the largest market share by far. So if you're going to learn one, learn that one. And this has a whole suite of things you can do in there. Working with big data sets in the cloud is, of course, where this relates to big data. There are a lot of data science specific tools on AWS, like the EMR, which is a way to set up Spark clusters in the cloud; Redshift, which is specialized database; pipelines, which is ETL pipelines. There's a lot of ML tools. So there's a huge pile of tools here. Again, this is all above and beyond, but if you can learn a few of these tools, maybe how to set up an EMR cluster and how to work with Redshift a little bit, that really does give you a huge leg up. All right, we got all these skills. How do we gain them? There's really 4 primary routes from my mind, which are online classes, getting a degree, a certificate program, and boot camps. I will warn you sort of ahead of time, the quality of all of these varies wildly. So there are great online classes and terrible online classes, and great boot camps like ours and terrible boot camps like all of our competitors, obviously. But no, there are good ones and bad ones. These online classes are often what are called MOOCs, multiple user online class. I forget what the second O stands for. But lots and lots of people in this class. These are great in some senses, in that they're a good way to get started and sort of lay the groundwork. You can do them usually at your own pace. They're cheap or even free. But there are many of these. Again, the quality varies massively, and you get very little guidance here. You're mostly on your own. Maybe you get a forum to work with. So for something that it takes a long time to absorb, like learning to program in the first place, a MOOC actually is often a great choice. Or it's a good choice to sort of get your feet wet with the topic. The degrees are nice in that they're very thorough, but as Sierra said, they don't give you much real world experience. I guess the online classes don't either. But they are very time intensive, very expensive, very expensive. And they also vary a lot. Oftentimes they're not actually run by the university, or run by a third party. They can carry more cachet, and they give you some projects to show up. We'll talk about projects in a moment, why they're important. The boot camps are sort of a balance between the two, and they are intense, they are fast-paced, they cover a lot of ground very quickly. They're often very thorough, maybe not as thorough as spending 4 years on a degree, because you're working with these programs for 8 or 20 weeks. They cover really the groundwork. They usually include a project. They usually include some sort of career-focused thing, like working with resumes, interview practice, which is really important. And so there are just many different options here, and you need to find the balance that's right for you. Again, getting your feet wet, MOOC's often a good place to start. When you're ready to actually dive into it, a boot camp is a great place to go, or if you've got lots of time and money, look into a degree. All right, so I've done that. I've built up my skills. What now? Well, again, build up your skills. Practice. This is so important to practice. Get your hands on this. And there's a lot of good places to practice online, both just things you can find where you can do some exercises, and a lot of projects you can find. And projects are super important here. They're going to help you sharpen your skills, get out of the classroom and actually do things. And they're going to give you something to show off. So when you're talking to a potential interviewer, if you can show them a portfolio of data science projects you've done, that carries a lot of weight. That's huge. These projects, of course, can be any number of things. A project you did because you were interested, a class from class, something you did in your professional life. There are, again, many available online. Kaggle is a source of these. Kaggle has its pluses and minuses, but it's a good place to find ideas and projects. If possible, you want to start this project, do it yourself from beginning to end. So that you start from, hey, here's a question I want to ask. I found myself some data. I did all the analysis. I put it together. I made some sort of communication, some end product. This emphasizes that you know what's going on. You want to emphasize solving a problem and not just, I did this because it was cool, because that's going to read very academic, and that's not what companies are looking for. And this shows that you're engaged, that you're active, you're working on this, and that you're competent. Of course, when you're looking into getting into the field, leverage what you already know. If you do have a background in finance, try to look for data-related roles with finance, because that context that you have is very valuable to companies. There are also a lot of junior roles you can look for. Junior data scientist is a role that still exists. Data analyst roles, these are sort of the entry level of data science roles. They require masters and experience, but there's the entry level for data science. There are actually also any sort of data related role can help. If you are a software engineer and you can get moving into a more data focused software area, that can give you a way to sort of transition into data science. So don't just look for data science roles, but look at a sort of a slightly broader net. Where does the Data Incubator come in? Well, I'm again only going to really talk about the data science program. There is also a data engineering program. And our data science program is either 8 weeks full-time or 20 weeks part-time. And we cover the most important topics. So we cover dealing with data wrangling, machine learning, both the basics and some more advanced topics, SQL, data visualization, putting this into a business context, doing distributed computing, we use Spark, doing neural networks, we use TensorFlow. And so we offer you a grounding in these basics, a chance to do exercises on them every week so you get your hands on and you actually know what you're doing. Again, that's so important. We also make you do a capstone project, which is a project that it's mostly self-guided. The instructors will be working with you throughout this, so you're not on your own in that sense, but you will be directing it yourself. You will decide what the project is, what question you want to ask, how to put it together. Instructor, again, will work with you throughout. And it's a chance, again, to show off those skills from beginning to end, to show that you know how to do everything a data scientist needs to do. And we are going to push you hard to make sure that A, you get it done and are doing the right things, and B, that you're doing something that is clearly practical and useful. And then during our program, you also have a lot of career-related stuff, how to deal with interviews. We do how to build your resume for a data science system, we do a lot of interview practice. So we have basically every week, we do different kinds of interview practice for interviews you might run into. All right, so I think that is enough for now. So I'm going to open the floor to questions.
We have a couple questions in the Q&A, Rich. I can just hear. So this first one says, can you please throw some light on the testing tools? I'm more interested in time series testing tools, also best GUI for Python, although it is mentioned Jupyter will be used. Are there any alternatives?
I'll address the second part first. So a GUI for Python is something you have to be a little bit careful about. I think what you meant was a development tool. So something like Atom or PyCharm. We use Jupyter notebooks just because they're convenient for us. But if you're doing real Python development, you want to use a dedicated IDE. So again, Atom and PyCharm are probably the most common. There's several others, but that's probably where I would recommend going. I think Eclipse has a Python mode, but I'm not going to swear to that. As to the testing tools, there are many. And the most common one in Python is PyTest. And these, again, set up automated tests of various natures. And they hook into your code and run your code and make sure it is doing what you think it should. So you set up a suite of tests. Time series is There aren't time series specific testing tools. That's, I think, asking a different question, which is how do I work with time series, which I'm not even going to attempt to address because I don't want to spend 20 minutes on it. But there are testing techniques for time series, and that's something that you'd learn as part of our program or some other time series focused machine learning process.
And our other question in there, how much time is spent developing the standout skills?
It's really up to you. If you're, I'm not even sure how to answer that, but the standout skills can take months to years, depending on what you're trying to pick up here. So, if you're looking at this takes months of practice. You're not gonna be able to pick this up in a week. You gotta make a lot of attempts, a lot of playing with it. Something like natural language processing, you actually pick up a little bit quicker. This might only take you a week or two. The time series, to at least get the basics of natural language processing, time series is a somewhat more complex topic. You might be able to get a good handle on it in a couple of weeks, but it takes months to get a real good feel for it. But they vary a lot. And I can't say that there's a fixed timeline on any of these. I think maybe the question was, how much time should I be spending on the basics versus the more advanced? Maybe that was the question. I would say, obviously, do the basics first. If you don't have the basics, you're going to be in trouble in an interview. Once you have those basics under control, then you can start looking at adding in some of these more advanced topics. And really, you should be picking ones that you think are interesting and useful and relevant to what you're doing. I'm not going to give you a priority list because it really depends on what you're trying to do. So, if something sounds interesting, I'm really interested in other kinds of databases, then learn about NoSQL. Or I'm really interested in learning an extra programming language, then do that. Now, this is actually quite a larger time investment. Learning C++ is a huge time investment. I would, however, recommend learning Git.
I'm actually going to pause in the Q&A. We have a couple more program slides that we wanted to share, and then we will reopen it. So we'll get to your questions in just a moment here, but it might answer some of the questions that you have at this point. So just picking back up here about our program specifically, we see questions quite a bit about scholarships and if we offer any scholarships to our programs, and the answer is yes, we do. We admit two types of students into our data science and data engineering programs. Fellows are offered tuition-free scholarships to our full-time program, and we offer a limited number of these scholarships to highly qualified candidates. Fellows are expected to leave any current employment to attend our programs and are expected to interview exclusively with our hiring partners. Scholars are the other types of students that we admit into our programs. Scholars will pay tuition to participate, and they are not required to interview solely with our hiring partner network and may maintain their current employment. Scholars still have the same access to curriculum, resources, and tools as our fellow students. There's really no difference there. And full tuition scholarships are not offered for the part-time program. I've also seen some questions about employment after the program, and a big component of our program that we really pride ourselves in is helping our students not only grasp data science concepts, but also get placed in that field. So we see typically about 82% of our students are employed within 6 months of completing the program, and 97% of our students that go through our program are currently employed outside of academia. And those are really great numbers. We're very proud of those and have worked hard for them. And that's really part of the challenge, is not only learning the content, but being able to transition into a data science role. And that's where our program stands out, because we help you to do both. I've also seen some questions about alumni. Where are our graduates working? What are they doing? So we see our graduates are working in about 55 different industries. And some of the most common industries we see are computer science, internet, IT, financial services, and biotech. And some of the typical job titles we see are data scientist, data analyst, research scientist, software developer, and product manager. These titles and roles vary depending on the company and industry, but these are some of the roles that we've placed in the past. And then here is a short list of our hiring partners, if it'll allow me to change the slide here. So it's a short list of our hiring partners. As I mentioned earlier, many of these companies are also hiring for our data engineering roles as well, but we are focused on building out a separate network of hiring partners dedicated solely to our data engineering program. We also get quite a few questions about financial options if we offer assistance, and the answer is yes, we do. In addition to our scholarships, we've partnered with LEAF to provide an income sharing agreement. It's a great option for many of our students. You can participate in our program with just a deposit down, and you won't be required to make any payment until you've graduated and are working and earning more than $40,000 annually. We also provide loans through Ascent, and Ascent offers 3 options, 1 being deferred repayments, 2 interest-only repayments, and 3 immediate repayments. And lastly, for many of our part-time programs, companies are willing to sponsor or pay for their employees to go through our program. It's a win-win. You get to learn great stuff in the evening and be able to apply it to your job during the day. So if this is something you think your company would be interested in or you would like to present to them, we do have a letter we can provide you that will help lay out the program and all of the benefits of attending. So where are we at right now in our admissions cycle? Well, we run multiple cohorts a year, and our spring cohort is starting in April, but the application for our summer 2022 cohort is now open. Our summer session, full-time session, will run from June 27th to August 19th, and our part-time will run from June 27th to November 11th. And as I mentioned earlier, the full-time cohorts are 8 weeks long and the part-time cohorts are 20 weeks long. And some specifics about our applications: we ask that you submit your application by March 25th for the early admissions deadline. You'll then have 72 hours to complete the coding challenge from the time that you open it, and the final challenge deadline is March 28th. You can't complete the challenge unless you submit the application. So just in general, I recommend you complete the application and challenge sooner than later to avoid any technical issues. We're unable to reopen the application or challenge after those deadlines. So that's for our early admissions. We do offer a regular admissions after our early admissions cycle. You may be wondering, what's the difference there? Well, we evaluate applicants on a first come, first served basis. So if you want a better chance of getting a fellow spot, or just knowing earlier for planning basis, if you've been accepted into the program to secure financing, I absolutely recommend applying for our early admissions application. We also offer a priority enrollment package for our programs that includes access to a Python training course, early access to career services, and a one-on-one with a data science resume writer, as well as $2,000 off your tuition for direct payment. So if you're interested in applying to our program, which of course we hope that you are, you can go to the dataincubator.com/apply to submit your application. And then if you have any questions about your specific situation, this presentation, or going through our application process, please reach out to us again at admissions@thedataincubator.com, and we'd be happy to answer your questions. So at this point, I will reopen the Q&A. If you have any questions that haven't been answered yet, please put them in there. We'll be happy to address those now.
So I want to quickly address something. One of the questions asked was about the standout skills, and I thought the question was about how much time should I spend developing them. Apparently the question was how much of the Data Incubator's time is spent on these standout skills. I would ballpark it at probably about 1/3 of the program is this above and beyond stuff, and 2/3 is the basics and the business context and that sort of stuff.
So our next question here is, how do you find more business-focused project without much business background or domain knowledge?
So this is a place where you might want to look into case studies. So if you can Google around for data science case studies, these will give you some ideas of the kind of things that businesses are looking at, and that will help you find some ideas of what a good business context would be. A good business focused project. But really the key is not, it doesn't have to be business focused, it just needs to be practical.
And another question is, if you can talk a little bit about the difference between the data science and the data engineering program.
Yeah, so the data science program is the one that I outlined. The big distinction is that the data engineering program covers similar stuff in the first half. So it does a lot with handling data wrangling, doing some basic machine learning, SQL and databases, and it also covers distributed computing and Spark. But the second half, they really differ. The data science program is focusing on visualization and more advanced machine learning, and putting things in business context. An engineering program is focused more on, hey, if I want to do this stuff, how do I actually build a database in the cloud? How do I set up a computing cluster? How do I set up a pipeline to process data as it comes in? How do I set up something to serve a model to people? So it's more focused on that sort of nuts and bolts doing stuff, particularly in the cloud. It's mostly cloud focused, AWS focused, as opposed to the data science, which is more about the business and more advanced modeling.
Another question here, what are the locations available this summer, and are there different hiring partners at different locations? So I can answer that one. All of our cohorts are offered online, so you are able to participate from wherever you are located. If you are interested in participating in person, we may have an in-person classroom in Berkeley for our summer session, so that is something we'll keep you updated on as well. But again, you can participate in all of the programs online. And our hiring partners are distributed across the US, so a lot of them are also open to remote hires as well. So it's not based off of your specific location or their location. You may be able to apply to hiring partners in a variety of locations. And then the last question I see in here, are you working with active business problems directly with industry partners, or are they past problems? Also, what mechanisms are there for interacting with peers in between lectures for the part-time program, and how many students per cohort?
All right, so I can at least field part of that. So the answer is that the program as we constructed is not actively working with industry partners on problems they're trying to solve right now. That is not how we do things. We are looking at more example problems and previous problems that have been worked on, basically because we don't want to have to bow to the whims of industry partners all the time, and it helps us keep things more organized. It also doesn't bind us to those particular partners, so it would be a little bit unfair to our other partners. In between lectures, we have active Slack channels that people discuss. We also have Zoom channels that people can pop into and discuss. So that is basically how we do that. There was a third component, which is how many people in a typical cohort, but I think Sarah, you might be better answering that than I am.
Yeah, so in the part-time program, we see about 20 to 30 students in those cohorts. It varies cohort to cohort, but that's about the average. And then the next question here, what is the minimum background and work experience required to apply to your program? So we ask that our applicants have at least a bachelor's degree at minimum with 2 years of relevant work experience. Or if you have a master's degree or PhD or one that's in progress that you'll be completing soon, then you would be eligible to apply. The last call for questions. I think we could take one more. And if you have a question that you don't feel comfortable asking in a group setting, I think we've put our email in the chat, but we might want to put it in there one more time. Feel free to email us at admissions@thedataincubator.com. We will be happy to schedule a call with an enrollment counselor and get those questions answered for you. Okay, everyone, I'm not seeing any questions. Again, thank you so much for joining us today. We hope this was helpful for you. Again, please reach out to us and get those applications in for early consideration as well.
Thank you, everyone.
Thank you, everyone. Have a great day.